We are solving now question number 3 of this kinematic topic for mechanics. The question is that a ball moves on the horizontal surface of a billiard table with a deceleration of constant magnitude d meters per second square. The ball starts at A with a speed of 1.4 meters per second and reaches the edge of the table at B 1.2 seconds later with a speed of 1.1 meters per second. Find the distance AB and the value of D. Then we will proceed to the second part of that. Since let's say this is question number 3, where ball is going to travel from A to B position, where at A speed is 1.4 meters per second, and that is U. At B, speed is 1.1 meters per second, and that is equal to V. And this time is taken in between A and B is 1.2 seconds. Then we are going to calculate this D, which is the deceleration. We know from the equation of motions, V is equal to U plus AT, where V is equal to 1.1, U is equal to 1.4, A is D there, and time is 1.2. So D there is equal to 1.1 minus 1.4 over 1.2, or D is equal to 0.3 over 1.2 negative, and that is equal to negative 0.25 meters per second square. For the second part of this question, you are going to calculate the speed of that object. We know one thing, that you can use this equation of motion 2as is equal to v square minus u square, where 2s is a value is 0.25, distance is s there, equal to 1.1 square minus 1.4 square. So s is equal to, after doing the calculation, it is equal to 1.5 meters for the distance from A to B there. So we have calculated the two parts of this. First, the deceleration, and then the distance from A to B there. Now, in the next part, AB is a straight angle, is at a right angle to that edge of the table containing B. The table has a low wall along each of its edges, and the ball rebounds from the wall B and reaches directly towards A. The ball comes to rest at C, where the distance BC is 2 meters. Find the speed with which the ball starts to move towards A, and also the time taken for the ball to travel from B to C. And in the last part, sketch the velocity time graph of this motion of this ball from the time that it leaves the A and until it comes to the rest at C. Along on these reaches to the values of the velocity and the time when the ball is at A, B, and C there. So in the second part, the ball is bouncing from B towards C, and we are going to calculate the speed when it comes back from B to C. At C, it is coming at rest, so final is 0 here. Here we don't know the speed at B there. The distance between BC is 2 meter there. So we will calculate the values of this unknown in it part. We know that U is unknown, V is known to us, distance is known to us. So we can use this equation 2as is equal to V square minus U square. 2, we know that acceleration is minus 0.25. Distance between these two is 2 is equal to V is 0 square minus U square. So that is 4 into minus 1 is equal to minus U square, or U square is equal to 1, or U is equal to plus minus 1. So it is positive 1 when it is moving away from B towards the point, and taken as to be minus 1 when it is coming towards back to the position A there. So U is equal to basically 1 meter per second for the speed of this object there. Then we are going to calculate the time it took from B to C there. We know that S is equal to UT plus half AT square. S is known as to be equal to 2 meters. U is going to be equal to 1 into time is T there plus half acceleration is 0.25 into T square. So that thing is equal to 2 is equal to T plus 1 over 2 into minus 1 over 4 into T square. By taking T square is 1 over 8 T square minus T plus 2 equal to 0. That is T square minus 8T plus 16 equal to 0. Or T minus 4 equal to 4 square is equal to 0. Or T is equal to what? 4 seconds. So that means what? It took 4 seconds to reach from B to C there. And the last part of this one is you are going to sketch the velocity time graph and show the positions of A, B, C there. Let's say it is O. It is A there. And at A point, its speed is 1.4 meters per second. So the time is 0 and the speed is 1.4 there. Then it is moving towards B with a speed of 1.1 meters per second, and it has taken 1.2 seconds for that. So it should be like this at B position, where the time it took there as 1.2 and the speed is 1.1 there. Then the ball is bounced back towards C, and with the initial speed of U there equal to 1 because it is going backward to A. So this is, let's say, position D there, or we can call it as C. So that is going to give us the speed of that object is minus 1, and the time it has taken there as 1.2. So 1.2 and minus 1 is the position at the C there. Then it has taken 4 seconds to reach from B to C. So here it is time is 1.2. So 4 seconds further it will become 5.2, and it is going to be at rest at the position B there. So this will be the C position. So it will be 5.2 and 0 there. So let's mark this thing as D there. So these are the positions of A, B, and C, where at the point A, its speed is 1.4 meters per second, at B, its speed is 1.1 meters per second, and at the point C, its speed is 0. The time it has taken there as point A there 0, then to B 1.2 seconds, and then from C it is 0 there. So this is the complete solution of this question number 3 for this kinematic topic.